Welcome to Let's Talk Micro. Hello, everyone. Welcome to another episode of Let's Talk Micro. I hope you had a great week. As always, Let's Talk Micro it's available on Apple Podcasts, Spotify, Google Podcasts, Stitcher, TuneIn Radio, Overcast, Amazon Music, Pandora. Wherever you listen to your podcast, you can find Let's Talk Micro. I am also on Instagram as Let's Talk Micro, no apostrophe, and on Twitter as Let's Talk Micro 1. So go ahead and follow. I always like to post pictures of organisms. Also, here's a chance to see what I look like in an interview that I had the opportunity to give by Robert Harriman. He has a podcast and a website called Outbreak News. And there's an episode there which is titled Microbiology and the Clinical Laboratory Scientist. So he interviewed me about, what it takes to be a clinical laboratory scientist or med lab scientist in microbiology as far as education, what you need to do, what's the typical day-to-day. So go ahead and check it out. It was a great interview, and once again, thanks to Mr. Harriman for giving me the opportunity. On the last episode, I went over Coagulase negative Staphylococcus. I mentioned that as a group, they are typically commensal organisms. They are typically flora. However, some are known to be pathogenic or they are emerging pathogens. And a great example of this is Staphylococcus saprophyticus. It is a coagulase negative staph that is known to cause UTIs or urinary tract infections in young sexually active females. The colonies are very typical. They are very white. So as you see them more and more in the lab, you'll definitely start recognizing them. But this is one species that you actually have to identify. So you see the white colonies, you look at your patient's history, your gender, the age, and you see young females, typically 20s, 30s. This is a very classical presentation. So you need to perform an ID on it. But I did mention that normally with Coagulase negative staph, as a group, you don't need to identify it. An exception is Staph saprophyticus, like I just mentioned. But with others, you can release it as CNS, depending on the source, of course. And since for Staphylococcus saprophyticus, you don't need to perform susceptibilities on urine cultures, instruments like the MALDI-TOF come in handy for this. If we are using other systems, it is good practice to set up susceptibilities in case that it turns out to be another CNS. And this happens, while you're gaining experience. Like I mentioned, you tend to recognize it more and more. But in the chance that you are wrong, perform susceptibilities. And this is for when you don't have the MALDI-TOF. If you have a MALDI-TOF, just put it in there. You get an idea of Staphylococcus saprophyticus, and then you are done. The treatment in uncomplicated UTIs for this organism is very standard. So this is why susceptibilities are not performed. So with CNSs, there are also emerging pathogens, like I mentioned, and one of them is Staphylococcus lugdunensis. It is beta hemolytic, but not as strong as Staph aureus, and that hemolysis can take up to 2 days. It is implicated in abscesses, wounds, and endocarditis. So this is an organism that we rule out in the lab. And MALDI-TOF comes very handy for this because you see those colonies, that hemolysis that is taking up to 2 days. You set it up, you get another ID, and then you are done. You can result it as CNS, you can result it as skin flora. But if you get the ID of Staphylococcus lugdunensis, then you go ahead and perform susceptibilities on it. This organism is also significant because the oxacillin MIC breakpoints, or minimal inhibitory concentration, are the same as Staph aureus. What does this mean? Well, it means that they are higher than other CNSs. It's definitely a good episode, the one that I published last week. So go ahead and check it out when you get a chance if you haven't yet. I also talked about blood cultures and how do we proceed with CNS in blood cultures. So for blood cultures, you have nucleic acid methods and PCR methods that typically identify Staph aureus, Staph epidermidis, and Staphylococcus lugdunensis. Other Coagulase negative staph, they are typically identified as Staphylococcus species. Some of these methods, they actually also detect the MEK gene, which gives the organism resistance to methicillin or oxacillin. So, on the issue of contamination that I mentioned in the last episode, this also applies to other organisms that are considered skin flora. For example, with blood cultures, I mentioned that you have if you have coag-negative staph on one set, it is typically a contamination. If you have it on two sets, then you do an ID on it. And then if you have different species, it's considered a contamination. If you have the same, you will do susceptibilities because this might be the organism causing the disease, causing the septicemia. But if you have different species, then it is considered a contamination. Other organisms that you consider contaminants, you can have Corynebacterium species on one set, Micrococcus, and Streptococcus viridans. And when it comes to Streptococcus viridans, you actually use the same process that is used for coag-negative staph. For example, if we have multiple sets with Streptococcus viridans, we perform an ID to see if they're the same species. If so, then susceptibilities are performed. If not, then it's considered a contamination. And I mentioned that this is data that hospitals keep track of because you want to make sure that, and I keep mentioning it, your skin has organisms. You have normal flora in there. So the area has to be properly clean. So this information, we track it in the hospitals, and then it is used to educate staff to make sure that there's proper disinfection and cleaning of the area prior to collecting blood cultures. I also want to talk about hemolysis. So I mentioned that Staphylococcus lugdunensis is beta hemolytic. So is Staphylococcus hemolyticus. So when I talk about hemolysis, I am referring to hemolysis on your blood agar. Some organisms, they can look beta hemolytic and PEA, but not on blood agar. A great example of this, and this is an organism that we'll talk about in future episodes, Enterococcus faecalis. Actually, Enterococcus faecalis can exhibit all three types of hemolysis, but it is mainly gamma. Do you remember the types of hemolysis? Right? You have alpha, which is partial hemolysis, and it gives like a greenish color. You have beta, which is complete lysis, complete hemolysis. So the agar is clear. And then you have gamma, which is no hemolysis. But however, Enterococcus faecalis, when you have it on PEA, sometimes, it can look beta hemolytic. So you have to make sure that you check the hemolysis on your blood agar plate. Staphylococcus aureus is hemolytic on both agar, blood agar, and PEA. Staphylococcus epidermidis can have sometimes, hemolysis on PEA agar, but not on blood. So make sure you correlate your colonies if you are working from the PEA plate. If you cannot do this, let's say because you have Proteus swarming on your blood agar plate, then go ahead and do an ID if you have enough organism. If not, subculture it to rule out your pathogens. And all the coag-negative staphs, they all grow on blood, chocolate, and PEA agar. So now that we have gone over CNS or coagulase negative staph, I want to talk about other species of gram-positive cocci clusters. One of them is Micrococcus. This genera, they are normal flora of the skin. It has unknown virulence factors. Your colonies are small to medium in size and non-hemolytic. And as far as pigmentation, they can be yellow, white, tan, orange, or pink. And I will say that the yellow pigmentation, the yellow colonies, are the ones that we most see in the lab. So an example of Micrococcus is Micrococcus luteus. It is one species that we see. The colonies are yellow, and they grow slower than staph. You will see fully formed colonies after a day, closer to 2, I will say. And yes, you sub out, and when we say, we subculture, but in the lab, we say sub out. So you sub out, let's say a Staph aureus, And after 18 hours, you have beautifully formed colonies, sometimes even before then. So this is not the case with a micrococcus. You saw about a micrococcus, and after day 1, the colonies are very tiny, and this is the presentation that we have in blood cultures. The instrument flags them positive, you perform your gram stain, you play your media, and then when you go to read them the next day, they are still very small. So it will take closer to 2 days. As far as micrococcus and sources, so you typically will see it in blood cultures. Might see it in other areas, but in blood cultures is where you will see it the most. The gram stain is gram-positive cocci in clusters and tetrads. Very beautiful. Even from colonies growing on plates, not from blood cultures, you can see the beautiful large clusters of cocci. So it's a very nice morphology. And then you have your clusters, you have your tetrads. And then I mentioned that you have instruments that can identify Staph aureus, Staph epidermidis, Staph lugdunensis. So some of these instruments, they don't identify Micrococcus luteus. So this is a typical presentation when you have blood cultures, right? So the instrument flags them, and then while you're doing the gram stain, you see gram-positive cocci in clusters. You will set it up in one of these instruments, so you can try to get an ID. Then the ID is going to come back as, like an unidentified or none of the targets detected. So then the next day when you're reading it on the bench, you look at your blood plate, and then you have those small yellow colonies. And as far as chocolate agar, there will be like a very faint growth. As far as identifying it, so you can presumptively identify it using a microdase disc, which is a modified oxidase test. So before you perform this test, you need to make sure that your organism is a gram-positive cocci. And I talked about the microdase disc. If you want to learn more about it, go ahead and check out episode 8 of this podcast. On that episode, I go over in detail about it. So you can also identify it using instruments like Vitek or Molditov. And susceptibilities are typically not performed. Like I mentioned, it is typically normal flora. But like other organisms of its kind, it has been implicated in infections. But those are typically in immunocompromised patients. And these infections include endocarditis, pneumonia, and sepsis. And I always like to talk about presumptive identification, which is, when you can identify the organism based on certain criteria, right? Great examples were the, Staph aureus, catalase, coagulase positive, and then beta hemolysis, CNSs, right? Catalase positive, coagulase negative, and unless you have Staph lugdunensis, you typically can just release the ID as coagulase negative staph. And then this is another example that if you have a microdase disc, the colonies look like Micrococcus, and then you have this positive microdase disc, which is the modified oxidase, you can go ahead and call it Micrococcus species. But if you don't have it, then you have to, put it on the Molditov. If you don't have that, then you can go ahead and place it in another instrument, such as the Vitek, and that's okay. But like always, any deviation from criteria, then you have to ID it by an actual instrument, right? If Staphylococcus aureus is non-hemolytic, if your coagulase is questionable, you need an ID. Let's say with Micrococcus, if you get an iffy result on your microdase disc, then you need to identify it by another method. But they typically, they are really good team players when it comes to testing. So you get some really good results on that microdase disc. And then at that point in time, you're done with it. So you see the colonies, you do the testing, it's positive, you can finalize that culture. And then, of course, if maybe the physician later wants susceptibilities, that's up to them, but they are typically not performed on Micrococcus. So the last organisms that I want to go over is from the genus Aerococcus. They are not catalase positive, like the other gram-positive cocci that I have discussed, but they are gram-positive cocci in clusters, and you do encounter them, especially in urine cultures, and to a lesser extent on bloods. There are two species I want to talk about. One of them is Aerococcus viridans. It is considered a contaminant in cultures, but it has been seen in endocarditis and bacteremia, but this doesn't happen too often. And then the other is Aerococcus urinae. This one is actually implicated in urinary tract infections or UTIs, and this happens on patients that are predisposed to infections, such as diabetic patients and patients with indwelling catheters. So Aerococcus urinae is typically seen on elderly patients, and we definitely rule it out on this patient population. So the colonies are alpha hemolytic, and they're very tiny. You typically have a presentation where you have urines from elderly patients. Let's say you have an E. coli growing very strongly, and then you see these tiny alpha hemolytic colonies. When you see this, you need to rule out Aerococcus urinae. And how do you do this? Well, depending on what you have, if you have enough colonies, go ahead and you can do a wet mount to try and see the clusters, and you typically can. You can do a gram stain, but you might not appreciate the clusters that much, depending on the particular strain. So you can always sub it out, and then if you have enough, you can do a PYR testing, which for Aerococcus urinae, it's PYR negative. And then, of course, if you have a MALDI-TOF, if your facility has a MALDI-TOF, that's one of the easiest ways. You have enough growth, put some colonies on that MALDI-TOF, you get that idea of Aerococcus urinae, and then you're done. If not, then you will have to rule it out by using another method, such as the Vitek. So this is how it typically goes. If you have, you have alpha colonies, alpha hemolytic colonies, you do a gram stain, or you do a wet mount, you see clusters, you go ahead and do a PYR. Your PYR is positive, then you rule out Aerococcus urinae, and you have in all likelihood an Aerococcus viridans. But if your PYR is negative, then you need to perform an ID on one of these instruments to make sure that you rule it out. If your ID comes back as Aerococcus urinae, you don't do susceptibilities on it in the lab unless they are requested. So this is another organism where MALDI-TOF comes in very handy, because you can either finalize the culture based on what you get, right? So if it's not Aerococcus urinae and it's something that it is skin flora, you can release it as urogenital flora. But if you get the ID of Aerococcus urinae, then you release that ID and you're done. So MALDI-TOF has a lot of pros and definitely has some cons, but it helps you finalize cultures faster, so the patient can go on treatment if needed, rather than sometimes you're subbing out, you're subbing and subbing. The instrument doesn't identify like Vitek, and then you're spending all this time, and maybe the patient has to switch on antibiotics. As far as Aerococcus viridans, you can see it on some blood cultures, but however, it will not be identified on one of the PCR nucleic acid methods. I talked about the Micrococcus presentation, where you see gram-positive cocci, you put it on your blood culture instrument, ID comes back as not detected or unidentified, and then you see the colonies on your plate. So this happens to a lesser extent with Aerococcus viridans. Same presentation, gram-positive cocci in clusters on your gram stain, unidentified by your blood culture instrument. So keep this in mind. And to you students out there, because I have seen sometimes, that when you're reporting gram stains, I'm talking about in school, not at work. I've seen students sometimes that use the term gram-positive Staphylococcus or gram-positive Streptococcus, and that is wrong. When you're doing gram stains, it's either gram-positive cocci or gram-positive cocci in chains, gram-positive cocci in clusters. But now, if you're listening to this episode, you know that calling something gram-positive Staphylococci when you have gram-positive cocci in clusters, it is wrong, because there are definitely more organisms out there that are gram-positive cocci in clusters. So always keep this in mind. If you release something as, and I try to tell students this, if you release an ID as gram-positive staphylococcus, you're telling the physician that you have a staphylococcus species. So they might be thinking of Staph aureus or a CNS. And from what you have heard from this and the last episode, the pathogenesis of these organisms, it's different. Typically, Aerococcus viridans and Micrococcus, they tend to be non-pathogenic. Whereas Coagulase negative staph, you have some definite pathogens, like Staphylococcus lugdunensis, Staphylococcus saprophyticus, and some of the other ones, like Staph epi and Staph hemolyticus, even though they are typically non-pathogenic, they can cause disease, like endocarditis. So you have to keep this in mind. So it is always good, and I mentioned this on the interview that I had with Robert Harriman. What makes you a good microbiologist, a good clinical laboratory scientist, one of the things is always to educate yourself, to read, to make sure that, this is a field that it takes so much time and years of practice. So always educate yourself. And when you report something, always start at the most basic level and then build up, right? Gram-positive cocci, if you cannot, if you are able to tell the clusters or chains, you can report that. And then from then you start building up. But no, don't start, saying things like staphylococcus, gram-positive staphylococcus, because that is wrong. You don't know what you have at the point in time that you are looking at the gram stain. And that, my dear audience, it's the end of this episode. I hope you enjoy listening about Coagulase negative staph and other gram-positive cocci in clusters, because I definitely enjoy talking about it. As always, thank you for the support. Continue bringing that motivation to what you do. This is very rewarding work, and we contribute so much to the health of the patients. So continue bringing that passion, continue educating yourself. That's only gonna make you a stronger clinical laboratory scientist, microbiologist, or in whatever you do. Always continue educating yourself. So stay motivated, stay safe, and of course, continue talking micro. Until the next time, bye.